All right, we got that typed in. We are going to go ahead and graph it, but I don't usually graph by hitting the graph button the first time. I will go zoom 6. Zoom. And this gives you a bunch of options. By the way, while I'm here, I highly recommend that you stay away from the zoom in and zoom out and zoom box. They do not work very well, but the ones after that are pretty useful. The one we'll mostly be using is zoom standard, which is zoom 6. I'll tell you what that means here in a second. So you can either scroll down and hit enter, or you can just type the number 6 and it'll automatically do it. And your graph should be looking something like this, which should look familiar. That's a polynomial graph. You graphed a whole bunch of these last year. Okay. I'm switching over to my calculator cheat sheet. Because I want to tell you a little bit about the window right now. All right, so window. The window settings, we can get to them. We're going to be messing around with them by hitting the window button. Let me draw a little picture to illustrate how this works. This is my calculator screen. Your calculator stores several numbers that determine how a graph appears on your calculator. So you can type the same equation in and you can make it look lots of different ways by zooming it in, zooming it out, stretching it in the X or the Y directions. How it determines how to do that are some variables stored in your calculator. The left edge of your graph, the number that represents the furthest on the negative x-axis is called x min. The right edge is called x max. The top is called y max, and the bottom is called y min. In the window menu, you can change these numbers. So if you're looking at your graph, and for example, the one that we've got on our screens right now, if it doesn't go down, if the window doesn't go down far enough to show the bottom of the graph, I can tell there's going to be a divot down here. This thing's going to turn around before it comes back up down here. I can tell it's cut off. In a minute here, we're going to go into our window settings and we're going to lower our Y min, so hopefully we can catch this. Does that make sense? All right. I want to tell you a couple other things you're going to see also. There's an X scale and a Y scale. And these control the tick marks. So those are those little ticks that you see along the graph, X scale and Y scale. When we start doing some application problems, our X values might represent like a distance. We may be talking like hundreds of miles. We don't want to, if we're going to be graphing out to like 500 miles, we don't want to have a tick mark every 1 unit, because then we would end up 500 tick marks. And with the resolution of this screen, that would just be a big old blob that would all blur together. So we would change X scale to something like 100. So we were seeing a tick mark every 100 instead of every 1. Does that make sense? There's some other things under the Windows settings. Just don't change those. Leave those alone. So let's go into our Windows settings and notice that we're not down far enough. It's going down to -10, I believe. We'll see when we go into the Windows settings. So hit Window. You see how the X and the Y are both going from -10 to 10? When you hit that zoom 6, you told your that changed all those values for you. Okay, so zoom 6 is the shortcut for going -10 to 10 in both directions. That might be worth writing down. Zoom 6 is your standard window. -10 to 10 window. And it's usually where I'll start when I'm graphing a function. And then usually I'll have to make some adjustments so I can see all the important features of the function. For our graph, it's not going down far enough. So which of these 4 values am I going to change? X min, X max, Y min, Y max. If I wanted to go down further, which one am I going to change? Y min. It's going down to -10 right now. What do you want to guess it's going to go down to? -20? I'm going to go -20. Let's try -20 and we'll hit graph. And we'll see, and you'll see your graph is now changed. It's showing some more down there. Now, not quite enough because we're still getting cut off there. Now, we could keep guessing and checking, but let me show you a faster and more efficient way to do this. Can I get your attention, please? Notice that this dip is happening at an X value of about what? It's -3, -4, something like that. -1. I think it's further to the left than -1. Somewhere over here, though, okay? What we're going to do now is we're going to look at the table, okay? Before we do this, let's write down some notes on table settings, because some of you may already have some weird table settings that we have to deal with. We get this by doing second window. Let's go ahead and do that on our calculator and see what the table settings look like. We just looked at the window. Same button, if you put second before, you'll get your table settings. So you're going to see a table start, a delta table, and then a couple of options, either auto or ask. Table start. This is going to tell you where your table starts. So the table is going to be an XY table, like you guys made a million of these in Algebra 1, right? So it's going to tell you what row your table is going to start at. Usually I'll have mine start at 0. But if you happen to ever bring up your table and it's starting at 5,000, you could scroll all the way back to 0, but it'd be way quicker to just go into the settings and make it go back to 0, okay? And then delta table, this tells you what the X values are going to count up by. Default's 1, but if you changed it to 10 instead of going 0, 1, 2, 3, it goes 0, 10, 20, 30, 40. If you change it to 100, 0, 100, 200, 300, okay? Let's leave it at 1. And then typically we want independent and dependent to be on auto. I can't think of too many times we're going to change that to ask, if at all. So delta table, that's how much it counts by. How X counts up. I don't really know how to put that in words. And then leave the last two on auto. So if any of that's not, 0, 1, auto, go ahead and change those settings now. And we get to the table then by doing second table. And I want you to think about how much easier Algebra 1 would have been if you guys had one of these things. You remember making like tables? You had to like plug, for one problem, you had to plug like 15 different X values into a equation to get Y values, and your calculator can just do it all at once. When you get to your table, I want you to go ahead and use your arrow button to scroll up. When you do that, you're going to start getting into some negatives, and then I want you to think about how is this going to help me set my window for this graph? We can kind of get a picture here of what kind of values we're seeing, what kind of Y values we're seeing. I see that it's going to go at least down to -50. Chances are it's going to go lower than that, but I can see it's going to go at least down to -50. I would go, and I always go a little bit past it. I'm sorry, if I'm moving too fast, stop me. So when I first opened up my table, it looked like this, and then I used my cursors to scroll and get some negatives up here. I scrolled negative up to get to the negatives. Are you seeing them? Yeah. Cool. And you see how like it looks like the lowest Y value I'm seeing on here is at like -50. So this is how we're sometimes going to get us a hint on like how far down we need to go. So let's go back to our window. Knowing what we know now, let's make sure our Y min is going to be significantly below there. I'm going to go -60. We'll graph one more time, and hopefully now we'll actually see where this graph bottoms out and turns around. Cool. So one of the big skills you guys are going to get good at in this first couple chapters is how to set up a window to show all the important features on a graph. There is a little bit of an art to it. Sometimes you can guess and check your way there. Sometimes you can use the table to give yourself some hints. What questions do you guys have at this point? No, the question is, can you use this cheat sheet on the test? No, but I'll let you know exactly what you need and be able to do on the test. There's some stuff that I'll help you out with. Okay, I'll help you out with errors. There's some very specific things I need you to be able to do though on your own. Okay, so setting up a window is going to be one of them for this first one. I'll be clear with you. Thank you for asking that question. And you're welcome to ask me as we're going through. If I introduce something, ask me that question. Hey, is this something I need to make sure I know how to do on the test? And I'll tell you right yes or no as we're learning it. Okay. I appreciate you. Thank you. Any other questions before we move on? All right, we're going to graphically analyze this function. So we've got a nice picture of what it looks like. I'm going to make a sketch. Remember, a sketch does not need to be perfect. It can be rough. I'm going to make a sketch of what this function looks like. Got a couple y-intercepts. So I'm just looking at my screen and making kind of a rough sketch of this. We're going to go through and highlight some important things on here. So I'm just going to show you a couple more things that we can find on our graph. So let's start off with a pretty key one. This actually isn't listed on here, but I do want you guys to be able to find this. Let's talk about the y-intercepts. All right. And we'll go to our notes in a second, but let me show you how I'm going to find that right now. Can I get you guys' attention up here really quick? So a lot of the important features that I'm going to be showing you for graphical analysis are going to be under the calculate menu. The calculate menu is above trace. So go ahead and hit second calc. And we've got several options. We'll be learning about the first 5 of them and using those extensively. Let's hit the first one. So go ahead and type 1 or hit enter over value. This is going to take you back to your graph. It's going to give you a prompt and ask you to type in a value for x. Now, if I'm looking for my y-intercept, what am I going to type in here? 0. And if you do that, it's going to tell you that 0, 6 is on your graph. 0, 6 is on your graph. So my y-intercept is 0, 6. All right, now you can use this second calc value to find any point that is on the screen, okay? So any x value that I want. So for example, if I were curious, it almost looks like -5 is an x-intercept, doesn't it? Am I counting correctly? 1, 2, oh gosh, it's so small. -5, is that right? -5 looks like it might be a y-intercept. Do second calc value, type in -5 and tell me if -5 is a y-intercept. I'm sorry, an x-intercept. I kept saying, is -5 an x-intercept? This point right here, is -5 an x-intercept? It kind of looks like it is. It's not, because when I put in -5, it told me the y-coordinate that went with that is 16. Okay, so -5, 16 is on the graph. So there is an x-intercept, but it's somewhere to the right of -5. We'll learn about how to find a decimal approximation for those later, okay? But that value button is useful for you when you've got an x value, you want to figure out the y value that goes with it. I'll show you how to do the vice versa of that later on. Question? Yeah, thank you for that. Good catch, Austin. So TI calculators, and I never figured out why this is. It probably has to do with like the super old programming language they were originally written in. There's a difference between a negative and a minus. So syntax error is almost always that. The other reason you'll get syntax error is if you don't match up parentheses properly. So if you have more opening parentheses than you have closing parentheses. Thank you for asking. And as those errors pop up, please ask me about them so that I can show you how to fix them. Has anybody gotten a dimension error yet? Invalid dimension error? Okay, window range probably means that you set a y min and a y max to the same number, or else you set a y min that was higher than a y max. So you're trying to graph the thing upside down. So check your maxes and mins and make sure that your y min is a lower number than your y max. Did that fix it? Yeah, that happens a lot. It's easy to do. Yeah, awesome. Hey, let me show you one more real quick. While we're talking errors, don't miss this because this is going to happen to you at some point. All right. Do you guys see when you hit y equals, do you see the little plot 1, plot 2, plot 3 on the top? Those are stat plots. We are not going to be using those in this class. It's really easy to accidentally turn them on. If you cursor over one of them and hit enter, that's going to highlight it and turn it on. And after you do that, if you hit graph, you're going to get error invalid dimension and like a whole bunch of stuff. Now, if you ever get this error, that just means you probably got a stat plot turned on. It's as easy to turn off as it is to turn on. You just arrow over top of that plot 1, plot 2, or plot 3, hit enter. Now it's off. It's not highlighted anymore. Something like that ever happens to you on a test, let me know. I am going to help you with errors, especially. You get a syntax error, dimension error, or something. I'll help you troubleshoot that. Okay. Question. Zoom, and then just hit the button 6. It's zoom standard. The actual function is zoom standard. Zoom 6 are the buttons that you push to get it. So I wasn't very clear about that. Zoom standard is what you're actually doing, though. You just hit the zoom button and hit the number 6, and it'll automatically select zoom standard. Yep. All right, so we're back to our graph here. We can now see everything. We're going to find local maxes and local mins. So first of all, are we comfortable with what a local max and a local min is? If I were to tell you that this graph has 2 local mins and 1 local max, can you see what 3 points I'm talking about? All right, let's see if we can find this local max here. This is actually the global max. And we're going to find coordinates for it. No, did I say max? I mean minimum. Thank you. Get late in the day here and I start flipping words, guys. So please let me know. All right, now, if any of you have ever used the trace function before, I want you to get used to not using it because it doesn't give you accurate. So watch me, okay? I'm going to show you the steps for this, and then I'm going to go through it slowly. I'm going to go once fast, and then once slow, and then I'll give you some time to write down some notes on your cheat sheet. Questions before? Oh, cool. Okay, so that's a shortcut for the, awesome, thank you. Thank you. All right, so let me show you this. You guys ready? Don't miss this. You're gonna be doing this a million times. All right, so I'm gonna find this local min here. So I'm gonna do second calc, and I'm gonna choose minimum. Don't try and follow me, I'm gonna go too fast. Just put your calculators down and watch this first time, then I'll go back slower. Second calc minimum. It's gonna ask me for 3 things, okay? It's gonna ask me for a left bound, a right bound, and a guess. When they say left bound, the calculator is asking me, where should I focus my attention? And I need to tell it, like, I am interested in you looking at specifically this portion of the graph. So when it says left bound, I'm going to take my cursor, use my arrows, and move the cursor a little bit to the left of that minimum. Over there, over there, over there, which one's better? Doesn't really matter, okay? And I'm going to hit enter. Sometimes it'll draw a little line there. The important thing is next it's asking me for a right bound. So now I'm going to move it a little bit to the right of what I'm looking for. And I'm going to hit enter again. So now I've told the calculator, focus your attention in between those 2 points. And then it asks finally for a guess. For the guess, just move it kind of close to that minimum, somewhere in between there, and hit enter. Now, if you're really close when you hit guess, it'll go a little bit faster, but like not that much, okay? So you got to give it a left bound, a right bound, and then a guess. And then finally, it will display your coordinates here. So let's do that again more slowly. Go ahead and grab your calculators. Do second trace to get to your calculate menu. Go down to minimum or type the number 3. For your left bound, move your cursor to the left of that minimum that you're interested in. Hit enter. How far to the left? Doesn't really matter. Use your left and right arrows, and you'll start seeing it. Yeah, yep. Just keep messing around with it. You'll eventually see it. Yep, after you got it there, hit enter, then it'll change to right bound. So now move it to the right of your minimum and hit enter again. And then it'll say guess, and then move it down kind of close to your minimum and hit enter. And the numbers you should be getting, by the way, we will be rounding to 3 decimal places unless otherwise noted in this class. So negative 3.714, comma, negative 52.454. Are you okay? 3 unless otherwise noted, 3 decimal places. Check in and see. You're all right. It's okay. It's okay. We're gonna be doing this so many times that you're gonna be okay. So our window got kind of messed up. So what I'm gonna do is go back to Zoom, and then 6 is our Zoom standard. That's gonna get us back to the 10 by 10. Now we know we're a little chopped off. Where's your notes? Which notes are we talking about? The packet one? Yeah, the one that I gave you on one's that one right there. Yeah. Next to the 4th. Oh, you got a times here instead of a plus. Okay. All right, so we're cut off down here. We need to adjust our window. We said, let's take it down to negative 60. Now we can actually see it. Okay, so go ahead and hit do second calc. Yep. And then minimum. All right, see your cursor up here. Use your arrow to move it a little bit to the left of that dip there. Just hold it down. A little bit more, a little bit more. That's too far. That's good there. Yep, hit enter. Now it's going to ask you for a right bound. So now use your arrow to move it a little bit to the right. It's going to come down. Keep going. We need it to be to the right of that dip there. Keep going. That's good there. Hit enter. Now it's going to ask you for a guess. So move your cursor close to the dip itself. Right there. Hit enter. And now it's going to show you the same X and Y coordinates that I got up on my paper there. Okay, you got it. You do that 2 more times and you'll be a pro. Okay, it's like anything else. It just takes a little practice. Okay, hey folks, we got to keep moving here. Let me get your attention, please. I think I got all the information I need to about this part of the graph. I want to get my other 2 max. They've got a max and a min here. And this, just from experience, I feel like this is going to be easier to do if I go back to my original zoom, because see how this kind of got squished when I zoomed out. So I'm going to go back to my original zoom. Do you guys remember the shortcut for getting to the original zoom? Zoom 6. That'll send it back to negative 10 to 10 in all directions. And I'm cutting off that dip down at the bottom, but that's okay. I know where it is now. So go ahead and use that same technique I just showed you to find the local max here and the local min here. I'll write my numbers up on the board here. See if you agree with mine. Obviously, when you do the local max, you're going to choose maximum instead of minimum, right? So go ahead and do that. And if you're having any trouble, let me know. I'll be around. Oh, and I forgot to give you guys some time to write down on your cheat sheet, but I hear a couple of people talking about writing what they're going to write on their cheat sheet for this, and I'm glad that you guys are remembering to do that. So those are my values. You should be getting something, well, you should be getting the exact same thing. Did you try it again? All right, folks, what we're going to do next is we're going to talk about increasing and decreasing. Really, really common mistake when we start dealing with increasing and decreasing. When we give intervals for increasing and decreasing, are we giving X values or Y values? X values, always X values. And you will probably see me make that mistake as you're going along, because it's really easy to look at the wrong coordinate when you're doing it. So when you look at this graph, do you see any intervals where it's decreasing? I'm seeing 2. I'm seeing decreasing here all the way down to there, and I'm seeing decreasing here. And we should be able to write down our intervals pretty easily because we've got all the X coordinates we need for this. So let's write down decreasing. See what you can do on your own. I'm going to write my answers up here and give you a chance to ask some questions about it. Check me on this, because last period I wrote down Y coordinates more than once. Let's look at work. And then you should have a couple increasing regions as well. Again, just always double check with increasing and decreasing that you're using X coordinates and not Y's. Hi, thank you. And then to wrap up this problem, we're going to do domain and range also. Domain. You guys remember polynomial functions all have the same domain? You remember what it is? Oh, and look at you guys using interval notation and everything. It makes me so happy. Yeah, the domain is negative infinity to positive infinity. You're going to love the day after our chapter 1 test when you can just write all real numbers. All real numbers? Well, there's a symbol for it, right? It's not an IR, it's an R. I'm forcing interval notation because it comes up so much that I want you to get to the point that you don't even have to think about it. Okay. You can still if you want. Yeah, half the people will still use it after this. The range is not all real numbers though, because this doesn't go down to negative infinity. Where does it start? What is the lowest Y coordinate we have on this graph? Yeah, good thing we found that minimum, huh? It does go up to positive infinity though. Yeah, a lot of people think this is IR. It's not IR, it's the double bar R. It's just like it's a fancy kind. It's a double bar. We talked about the double bar Z, right? For the integers. I think there's a double RN for something too. Natural numbers, maybe. Bless you. All right, hey, why don't we see how we do with this? Oh, this next one's got a super common error. Type that equation in your calculator and see what it looks like. And I'm going to tell you right now, this is kind of mean because I know for not for a fact, but pretty certain that about half of you are going to get the wrong graph when you do this, because super common error. But hopefully this will be the last time that you make this mistake. If you do, you got it. So now I'm guessing that less than half will make the mistake. Your graph should look like this. If it doesn't, you have forgotten about parentheses. Parentheses. We got to be super careful with rational functions. Rational functions are the things with fractions. Shh. These calculators can do a lot of stuff for us, but they are not that smart, okay? Your calculator is not going to know that you want to keep this 6 plus x squared in the top of a fraction unless you put parentheses around it. Same thing with this 4 minus x squared. So if you're not getting the same graph that I am, you can just use the fraction button that implies the parentheses. You can't. You got to type it in like that. Oh, you can. You're not going to be able to get. Yeah, can I borrow your calculator for a second? Do you mind if I put it on the screen? Some of your calculators may show some vertical lines where the vertical asymptotes would be. Whoops, sorry. Can I get rid of this, can I get rid of this horizontal line on here? Is that okay? Yes. Some of your graphing calculators are going to put these extra vertical lines in there. If you see that, that's just, don't worry about those, ignore them. They're going to end up being where your vertical asymptotes are. So that's a small error or a feature. Okay, question? Okay. All right, hey, let's sketch this graph. I feel like we don't really need to mess around with the window too much on this because I'm seeing all the important features that I need to see. It doesn't seem to be cut off anywhere. I'm hopeful. Hey guys, can I get your attention, please? Hey, I'm hopeful that you look at this and you're kind of envisioning those vertical asymptotes in there, even though you can't see them on your screen, or some of you can. And I'm hopeful that you're kind of envisioning a horizontal asymptote going across here too. But let's go ahead and sketch this. And then we'll go through and we'll do the same analysis that we did just a moment ago. You'll be happy all through chapter 2 when we're doing rational functions. Not really. It's kind of the older operating system includes them. The newer operating system, they kind of worked around it a little bit. Your calculator graphs from left to right, so it makes an XY table, and each pixel that it graphs is an XY coordinate. As it's going from left to right, when it hits this low point down here, when it hits this low point down here and goes up to here, it's actually drawing a line between that low point and that upper point, which shouldn't be there because it's not part of the graph, right? So it's yeah. So but it ends up being where the asymptote is, so it's kind of useful. All right, guys. Let's talk about let's talk about these asymptotes really quickly. There's a pretty quick way to make sure that these asymptotes are where we think they are. We can kind of eyeball it. It looks to me like they're at 2 and -2. which of the features we've used already today do you think we could confirm that 2 and -2 are where our vertical asymptotes are? Yeah. Table would work. If we see blank spots on our table there, that would confirm that. The other one I would say is if you use that value, second calc value, if I plug 2 in, I should not be getting a y coordinate, right? And if you give it a number that does not have a point on the graph, it'll leave it blank like that. So that's confirmed to me that there are asymptotes at 2 and -2. Do you see any local maxes on this graph? Me neither. Me neither. I do see a local min though. And this is important, folks. I'm about to point out another thing that causes a lot of people a lot of confusion. I know we're getting close to the end of the day and it's a Friday, but stick with me here. I'm going to do my my minimum to try and find the coordinates of this min. And I want you guys to see this because you're going to run into this. And I'd rather you know what it is before you run into it than be totally confused. Let me zoom this in a little. Maybe a different operating system. Is yours saying 0? Oh, for the y coordinate? 3/2 is 1.5, isn't it? Oh, is that what that said? Yeah, it's trying to. Yeah, put them in decimals. All right, I want you guys to see this. Ooh, that's some cool aliasing. Do you guys know what aliasing is? You see how it makes that pattern on the screen? Okay. Okay, I need you to pay attention up here and then I'll deal with your problems because I got a problem too. Okay, are you guys looking up here? Don't miss this. Do you see this x coordinate that my calculator just spit out? -1.463e -6. Yours says something different. All right, hey guys, I need your attention, please, please. When you see something like -1.463e -6, that is scientific notation. That is telling you that we're doing -1.463 times 10 to the -6. 1463. So if I move my decimal place 6 places to the left, 1, 2, 3, 4, 5, that is the number that you're looking at right there. 0.00. Oh, I need another 0 there. 0.00001463. What is that number really, really close to? 0, okay? When you see a number like this pop up on your calculator, you need to read that as 0, okay? Calculators work in binary, ones and zeros. They're going to have what's called rounding errors are going to creep into calculators when you get close to 0, especially with rational functions, okay? You're going to look at this and you're going to say, oh, you nice little calculator, you did your best. I know you were trying to get 0. It just didn't quite get there, okay? So are you hearing what I'm saying? When you see a number like this, it is 0. I'm not writing that down on my paper. I'm writing 0, 1.5 for that minimum there, which also happens to be a y-intercept, right? All right. We're going to take some questions. Before we do, where are y'all going to find your assignment that you're going to be doing over the weekend? Oh, you guys are so good. You're so good. I will put my final analysis for this up on the screen. If you'd like to write it down. But we're going to call that good for today. Folks, I appreciate your attention. I'll be around to answer individual questions here. Oh, I forgot to mention something. Hey, this is going to come up later on. When we're talking increasing, decreasing, and sometimes with domain and range where we're doing this graphically with the calculator, some of the parentheses versus brackets are a little bit wishy-washy, okay? Especially increasing, decreasing. I think your book will always use square brackets. I don't believe that's correct, but I don't know. All right, let me stop this recording.